So metabolism, we kind of talk about this all the time in society, but most people in the context of I have a fast or a slow one based on if I gain or lose weight. But the actuality of it is metabolism is all of the processes our bodies use to turn our food and environment like sunlight into energy. And every cell and every tissue in your body requires energy to function and to survive. So this is happening in orders of magnitude we can't even comprehend all the time. And the primary fuels that our bodies use for these metabolic processes are glucose, which is a sugar, and fat. And inside of fat, if you click into that, there are different types. So most fat molecules don't dissolve in water, and so they can't cross this barrier that's around the brain called the blood-brain barrier. But ketones are a specific type. They're basically a repackaged fat molecule that can cross the blood-brain barrier. So it's kind of a specific fat that your body can produce, and it can be used by the brain for energy. So it's a very unique molecule. And most people are not producing ketones unless they're deliberately doing something like either fasting for extended periods or eating a super high fat diet. So like 80% of your calories are coming from fat. And in those circumstances, your body kicks into this mode called ketogenesis, where it's basically breaking down the nutritional fats and the adipose tissue on your body and turning it into ketone molecules.
That's pretty incredible. I guess in terms of how your body processes that, or how that, I mean, I'm guessing we'll get to this in a little bit, but is that a gentler fuel source for your body as compared to something like glucose?
Well, it's a different fuel source. And that's really what all of this research and ultimately what Levels is working on, is that we've now got the data we need to recognize that all calories are not the same. So there are these different molecules. I just laid out three of them. The fourth sort of macronutrient is protein. So we're basically consuming fat, sugar, and protein every day. And each of those molecules has a completely different implication for our metabolic processes. And those implications are hormones. So when you consume, you just think of the human body as a giant chemistry set, because that's ultimately what we are. And what you eat is just like pouring chemicals into the chemistry set. So when those chemicals arrive in the bloodstream after being digested, other chemicals have to respond to them. These are signaling molecules, and these are hormones that are basically marshaling resources. So, for example, with glucose, the glucose is the primary energy molecule in most modern people. So most of us are well fed all the time. We're sedentary. And so what we eat typically contains carbohydrates. Those break down into the bloodstream. And the way the body gets those out of the bloodstream is through this hormone called insulin. And insulin's purpose is to store things. The way it works is that it's like a key in the lock of every cell. So these cells have receptors. They identify insulin. When insulin attaches to them, they open up these transporters and glucose moves into the cell to be used for energy. Now, insulin, we call it an anabolic hormone because it is primarily focused on storing things. And when you have high levels of insulin, your body's constantly storing the glucose that's being released into your blood and turning it into body fat. Now, the difference is for fat, there is no insulin response. So fat can be readily stored on the body without hormones, and it can also be readily metabolized as long as there is no insulin in the blood. So imagine a situation where you're constantly eating a high carbohydrate diet that is also high in fat. So insulin is circulating in the blood, and it is preventing anything from being burned. It's basically only storing. And you're in a situation now that you can store the energy that you're consuming, but you can't access it for energy because insulin levels are high. This is a situation that can, for many people, go on basically daily for decades. And ultimately, when you are in this what's called hyperinsulinemic state, where insulin's always high, your cells eventually get to a point where they stop responding. The mechanisms are hard to explain, but just imagine like you walk into a kitchen and there are freshly baked cookies. You smell that. It's like a very strong smell. And then 20 minutes later, you're no longer aware of the smell. So your body has sort of adapted to the environment and is no longer sending that strong aroma, even though it's still there. This is how I would describe the insulin resistance process, where insulin is so high all the time that your cells tend to essentially desensitize to it. And the problem is that you're now in what's known as an insulin resistant state, which is where things go haywire. So insulin's constantly elevated. You can't oxidize or use the fat that's on your body for energy. And you're basically locked in this energy crisis where when you need energy, you can't get it because you're blocked, and where you can only add energy for brief periods of time as you spike your blood sugar and in the period between that spike and when it's sort of marshaled into fat stores. So anyway, all that to kind of describe the hormonal differences between the macronutrients we're eating. Carbohydrates signal insulin release, fat does not. And so that's a very big deal, especially in modern society where we're experiencing such high rates of metabolic dysfunction.